This is a worksheet for 2.1. We're recognizing patterns and sketching the next figure. We can see here we add a new row of 3, a new row of 4. The next figure would add a new row of 5. For number 2, we are shading in a quarter of the circle at a time, starting here and working our way around. The next figure is going to have the bottom right quadrant shaded. For number 3, we're adding a square each time, and then we're shading all but the upper rightmost square. So upper when possible, otherwise rightmost. So this would be the next figure in this sequence. For number 4, if we take this dot and we move it 2 points to the right, we end up here. And we move that 2 points to the right, and we end up here. And we follow that pattern to end up there. One more time, we count over 2, and we are down here for the next figure. So for number 8, if we count the number of objects in the pattern, we have 1 square, 3 squares, 5 squares, 7 squares. I think it's reasonable to assume that there are 9 in the next object. So in the same way that for number 8, we were adding 2 each time, we have to figure out what we're adding for number 9. Plus 2, plus 3, plus 4. So the next one's going to be plus 5, and we'll get 15. For number 10, we are adding 5, and our next number is going to be 25. For 11, subtracting 3, and our next number is 11. For 12, we are dividing by 2, and our next number will be 2. For number 13, we are adding 4, and our next number will be 4. For 14, we are multiplying by a negative 3, and our next value will be a positive 243. For 16, we had to create a conjecture about the product of any two odd numbers. So the product is the result you get when you multiply two numbers together. So if we look at all our solutions, 3, 5, 9, 15, 5, 25, 35, 7, 21, and 49, the one thing they all have in common is that they are odd integers. So the product of any two odd integers is also going to be an odd integer. For 17, we are completing this table. So 3 plus 5 is 8, divided by 2 is 4. 5 plus 7 is 12, divided by 2 is 6. 7 plus 9 is 16, divided by 2 is 8. 9 plus 11 is 20, divided by 2 is 10. And what we should notice is the average of any two odd numbers is going to be even. And more specifically, to say the average of any two consecutive odd numbers. So I guess another way to write that conclusion would be that it's also the number between them, as well as being even. So for number 18, the average of any two consecutive even numbers is an even number. So I take two consecutive even numbers, 6 and 8. I add them together and divide by 2, and I get 7, which is not even. So that's my counterexample. For number 19, any four-sided polygon is a square. Well, some four-sided polygons are squares, but I could just draw any of a number of four-sided polygons that are not squares to disprove this conjecture by finding at least one counterexample. For number 20, if I try even numbers, if I try odd numbers, regardless, I square them, and it comes out positive. So I'm going to call this one true. For 21, this is a problem about evaporation, performing an experiment, checking the water level over a number of days, trying to figure out the effects of surface area on evaporation. What we should notice in this water level row is that there is a constant rate. We are decreasing by negative 11 as we go from each cell to the next one. So for day 6, we would just take 125 minus 11. That'll give us 114 millimeters. So I think what we're saying here is that when the bowl is more full, there is more surface area. And when the bowl is less full, there's less surface area. But it's evaporating at the exact same rate. So I might come to this conclusion that the surface area of a body of water does not affect the rate of change of its depth by evaporation. Or in other words, it's evaporating at a constant rate regardless of how full the bowl is and how much surface area results.